chapter 1, 1.3, collecting sample data. So this will be the end of chapter 1. Key concept. So for this section, 1.3, we're talking about how you collect the data. That actually matters a lot, is how you gather your data. And it influences a lot of stuff. It's of particular importance to have simple, random sample. If data are not collected in an appropriate way, it could be useless. We talked about some of that Monday, didn't we? So we'll see some more examples of that. The gold standard. Here's the best way to collect data. Randomization with placebo treatment groups is sometimes called the gold standard because it is so effective. You guys know what they're talking about. What's a placebo? Fake pills, sugar pills, like they're saying here. Do you know what we're talking? What are we talking about here? What's placebos? Why do they use them? And what are we even doing?
Control.
Yeah. Yeah. So suppose you have a new drug that you think is working to do something. How do you test it? Do you just take a group of people and give them the drug? What if you have something you think is going to help people get over colds quicker? Remember, didn't I talk about last time airborne has actually not been proven to do that? But how do they test airborne? Would they just take a group of people, give them the airborne? Tell me about what you think about this study. Let me just make up a study here. I grab 100 people that have a cold. Grab 100 people with a cold, and I give them airborne. Oh, and I already know. Let's say the average time to get over a cold. The average time of a cold is, I don't know, 2.3 days. I'll just make up a number. And then I grab these 100 people, give them airborne, and afterwards I have a doctor measure how long till they get over their cold, and they get over their cold in 1.5 days on average. These 100 people do 1.5 days. So it's better, quicker. So airborne works. Well, what could be problematic about that study?
How do you know they just didn't get over it or take something else?
Yeah, how do I know what else they did? How do you know that these aren't just all people that are healthy and would have got over it they're getting over from other things anyway? What's that?
Or is it just luck?
Or is it luck? Or is it just in their mind? And we know the mind actually does things to the body. Lots of studies have proven that. If you think you're getting better, you start getting better, right?
If you think you're bad, you get better.
What's that?
Or if you think you're bad.
Yeah, both ways. Yeah, both ways. We've learned in the last 50 years, science has that the mind has a powerful effect on the body. There's a deep connection there. So what people so this study nobody would believe this study. There's nobody in the science world would believe this study. How could you do better? How could you improve that study? What if we took another 100 people and we gave them a placebo? Which means we tell them, you're getting the airborne too, but they're not really getting the airborne. They're just getting a sugar pill. They don't know it. Looks just like the airborne tablets. They taste just like the airborne tablets. They take them, and we have 100 that think they're getting the real deal that are not. They're getting the placebo, the fake, the nothing pill, that we know does nothing physically. And then the other 100 get the airborne that we're wondering if it does something. And then afterwards, we measure both groups. And we say, did you get better? How long till you got better? And what if this group took 2.3 days to get better, and this other group got better in 1.5 days? Then we start to believe a little bit more. That's stronger evidence. That's a better designed study. Because now we've ruled out mental things, haven't we? Now they all thought they were getting something, but these people really didn't get something. And the people that did, it made now the only difference between these two groups is the real thing, the airborne or the fake. So that's called a control, and we'll get more into this. I'm just giving you the big picture right now. That's called a controlled experiment, meaning you have a control group. This other group over here, this group, is called the control group because you use it to keep track of things so you know when your results are real and reliable. This group keeps control of the experiment because they're given nothing and they're a baseline to compare to. Does that make sense? So a control group, you give the placebo to, you give the fake to. So now if the control group takes it, and they also end up saying, yeah, we got better in 1.5 days also. Then you start thinking, okay, yeah, the airborne's not doing anything. It's all mental. We just got to make people think they're getting something. Right? It's all just mental. Nothing real is happening here. Or maybe we're measuring. There's also all kinds of things about how the doctor measures, and we'll get into all that. All right, so we'll go more of that. You know, it always reminds me of one of my favorite, this is actually real. One of my favorite studies was done, where was it? It was done in Houston. This was actually, I'm telling you a real story here. It was done in Houston. They did a study. It was a veterans hospital in Houston. And they were trying, was it Atlanta? It was Atlanta or Houston, I can't remember which one. It was a veterans hospital, and they were trying to do a knee surgery on some of the veterans to see but they weren't sure if this knee surgery was really helpful. You know how some of that stuff is. You talk to different people. I'm getting older now, so you know you're getting older when you talk to your friends and you're all checking in on each other's health. That means you're starting to get a little older. I'm getting there. I do that. How you feeling? Yeah, a little. Yeah. Anyway, so I'm kind of entering that zone. I know many of you are not in that zone yet, but yeah. So some things are kind of like it's debated whether back surgeries, knee replacements really work, don't work. Different people have different opinions. So anyway, they did a study on this to try to figure it out. They took 3 groups. They got people to volunteer for this study. 3 groups of people. They did a controlled experiment, just like we're talking about. One group got a certain kind of surgery on their knee. A second group got another kind of surgery. They had 2 different kinds of surgery they did in the knee. And the third group got a placebo surgery. That's the part that I felt was hilarious. Now, what do we mean, how do you get a placebo surgery?
Put them to sleep, cast it, tell them they're good.
That's right. They put them under, cut them open. Right? They got to have a decision there or they would know. And did nothing. Sealed them back up.
You can do that? That's legal?
Well, these people had to agree to it ahead of time. All these veterans, they were getting a free surgery, basically.
Yeah.
So they all agreed, you don't know which group you're going to be in. 1/3 of you will be in the fake surgery group. And the other 2 will be, we're going to randomly assign you. You won't, that's part of the deal. We can't have you know, because you're going to be telling us how you feel. And if you know you got the real surgery or didn't, you would, tend to skew the results, right? So they put them in, they really did this. They get these people to agree, they did the 3 groups, and then they took the data afterwards, and this is the part that cracks me up. The different groups, all 3 groups, reported improvement after the surgery. But the group that reported the greatest improvement was the placebo group. It's true. It's the truth. I'm not making up stuff. That group reported the best.
It's probably because they never went into anything in there. I've had a few knee surgeries, so once you get cut up, it's pretty bad.
It's all downhill from there, huh?
I've had them, so it's not the same.
Ooh, yeah. So that tends to make one think that the knee surgery is really doing nothing, huh?
I don't think so. I mean, my knee's far worse than it was.
That's been your experience, huh?
Yeah, from my experience, it's far worse now.
Oh.
5 surgeries, so it's...
Yeah. Yeah, so that's why they do these kind of things. They want to figure out, that'd be a bummer if you were like, you mean you cut me open, you didn't know anything? But that was part of the deal. And that result showed that, at least in that case, it didn't seem like the knee surgeries, it was all mental, right? It seemed like it was all mental. All right, let's keep going. Basics of collecting data. So statistical methods are driven by the data that we collect. There's 2 kinds. There's observational studies and there's experiments. So observational studies, is just when you just look and observe. I just looked and I saw this. An experiment is what I was just talking about. We have the 2 different groups. You have a control group and a group you give the actual treatment to, and that whole thing. So we'll get into that more now. So an experiment, you apply some treatment and then you try to see if it has an effect. So I'll move on. All this is in your notes already. And then observational study is, there we go. Observational study is just when you observe some characteristic, but you don't modify anything. You're not giving them a drug or giving them a surgery. You're just looking and observing. Like if I tried to say, what's the average age of students at West Hills College, Lemoore? I'm not changing them. I'm not changing their ages. I'm just looking and recording what their ages are and coming up with the average, right? Or a sample of 100 people to get the average for the whole school. That's an observational study. I'm just looking and recording. Whereas the other one, an experiment, you're giving them something and seeing if it has an effect, right? All right, ice cream. Now, we talked about this last time, didn't we? The ice cream and the drownings, right? Remember what the connection was? That, right, at times or areas that have more ice cream have more drownings? Because it's hot. The lurking variable is heat. It's hotter. So there's more people eating ice cream and there's more people drowning. Meaning ice cream is not causing drownings. So this is where we start to be a wise consumer of information. That's a lot of what this, both ends. You know, if you do statistical studies, you want to learn to do them well. If you have a job in which, you know, business or some kind of other situation in which you're going to use statistics to determine what's true, or more often you're a consumer of information, right? People in the information age, it's just pouring at us. People are telling us things. What do we believe and not believe? How do we be a wise consumer? So if somebody says, yeah, it's just the truth that, you know, that months of the year or locations that have more ice cream have more drowning, so ice cream's causing drowning. Well, I mean, that's silly. Nobody would believe that just because it sounds so silly. But people say things that maybe sound better, but the studies are just as bad. What if you really thought that ice cream maybe was causing drowning, which nobody would really think that. How would you go about actually proving whether it is or is not? This is just an observational study, right? They just looked around and said, hey, we've noticed that the different months in the year where there's more ice cream consumption, there's also more drownings. Ice cream must be causing drowning. Or like the cancer with the milk, or the Boy Scouts and the criminals that I gave you last time. So you don't just look. You don't just observe. If you're wondering if one thing is causing another, like if Boy Scouts are causing people to become criminals, or milk is causing cancer, or ice cream is causing drowning, if you're wondering about a causational relationship, you have to do an experiment, not just observe. You have to give one group ice cream and the other group not ice cream, and then record if one group drowns more than the other. Right? I know it's just silly. Obviously they're not. Right? Same thing with the milk. Give one group milk, the other group no milk, and see if cancer comes more or less. That would be a study whose results we should believe. So do you see the difference? That's how we avoid these errors. We make everything the same except for that one factor. That's called controlling for one factor. You take two random groups, everything's the same about them except one gets the milk and one doesn't. Or one gets the ice cream and one doesn't. Or one is a Boy Scout and the other is not. Right? The only difference being that thing you're trying to determine. Then you can believe the results. That's the idea here. That's an experiment. Instead of just here, the experiment is clearly better than an observational study. So don't believe things. Don't believe things are causational. So let me write that. Do not believe. It would not be wise. Do not believe causation. Like one thing's causing another, milk causing cancer, whatever. Only from observation. Use an experiment instead. Do you understand the difference of what I'm saying? Don't believe studies that simply make an observation and then try to determine causation. Try to get you to believe that they've proven one thing's causing the other just because they observed a pattern. Lots of patterns exist that have nothing to do with one thing causing the other, right? Causation. So how do we determine causation? Experiments, right? Where we make the only difference between the groups, the milk or the Boy Scouts or the ice cream. All right. So replication, I think that's obvious. You do the thing again and again. Design. Oh yeah, let's talk about blinding. So that makes sense, right? They use blinding. Blinding is a technique in which the subject doesn't know whether he or she is receiving a treatment or a placebo. Why is that? Why do we put that in there?
So we're going to think about it.
Yeah, because we're so mental. Huh. Right? So you give one group the real treatment, the real surgery, and the other group just thinks they had surgery. And you saw in that Houston or Atlanta, I can't remember which, Veterans Hospital in the 1970s when they did that experiment, mental was the biggest factor. The people that didn't get the real surgery felt better. They felt best. So it was all just mental. So the reason we do blinding in experiments is because we want to take out the mental aspect, right? We're trying to determine if the surgery is really doing something physically. So the way you determine that, the way you get around how mental we all are, is you lie to yourself, right? You lie to them, and you make them all think they're getting the treatment. Blinding. All right, there's also double blind. That's probably part of the problem. So what does double blind mean? Double blind, do you get it? You get what they're saying there?
The subject and the experimenter don't know.
Yeah. The subject doesn't know. Now, we've already had that. That was regular blind. The subject doesn't know. Who else doesn't know?
The experimenter.
The experimenter doesn't know. Both groups don't know. Both groups. And that is what they did in the Houston or Atlanta, whichever it was, Veterans Hospital thing in the 70s or 80s, whenever that was. That was probably part of the problem. Those doctors were blindfolded when they did the surgery. I'm just kidding. It's not that bad. but what? So what are they talking about here? What do they mean? How can the experimenter be blind? What do they mean? And why would they even do it? Yeah.
I remember correctly, I took a psychology class where
Yeah.
Every time they flipped the switch, there was a study they did to see how far people can take shocks.
Oh yeah.
Like,
I've seen that one
yeah,
too.
the person didn't know whether or not they were going to get shocked,
Right.
and the person who was doing the shocking didn't know that they were doing the shocking either.
Right.
So both groups didn't know
Right.
what the other person was doing.
Right. And then that reveals more things. Yeah. Part of the problem, especially these medical things, is the doctors. It's a judgment call, right? The doctor comes in and says, "Hey, is your knee better?" Or also, with when they let me tell you the big case they did this on. It was the smallpox vaccine. That's one of the most famous cases where they used a controlled, double-blind experiment, and it was very successful, and they pretty much wiped out polio in the West. Is gone, right? It doesn't exist in the West at all, and it was crippling. Remember, we had a president that had polio. Remember? We'll do a little history. I remember I'm a wannabe history, so every night I got to throw in history. I love history. So who was the president with polio?
Roosevelt? Oh, no.
Not that Roosevelt. It was the other one. It was FDR, right? Franklin Delano Roosevelt, the one that led us through World War II, right? Yeah, he was in a wheelchair. So yeah, he had polio. He was in a wheelchair from polio. So anyway, so that shows it was a regular thing. Normal people had polio back in that was the 40s, right? World War II, that was the 40s. Anyway, so, but they wiped it out. How they did it, Salk, right? Dr. Salk, the Salk vaccine. He was the one that first came up. Him and a lot of people around the same time came up, but they thought, we don't want to give this to the whole nation if it's not working or if it's going to cause a problem. They had to be sure, right, before they started giving it to every child. So they got to be sure. How'd they be sure? They did a big nationwide study. They took two giant groups. They had like 10,000, 100. It was like 100,000 kids in each group, and half of them were going to get the real vaccine, and the other half were not. And they had to agree ahead of time, and a bunch backed out when they heard the conditions. Like, I don't know, 50. I remember reading the study one time. Like 400,000 said, "No, thank you. I'm backing out." But the ones that agreed to go forward, they were blind as far as they didn't know. They were all given a shot, but they didn't know if it was just water or if it was the real Salk vaccine. So half were given the real vaccine and half were given just water. And the doctors who were giving, or the nurses, whoever it was, that were giving the shots didn't know. Now, why was that important? Because the doctors, you think, well, then who did know? There was an administrator over the whole thing that knew. So there was some administrator, a board of directors who knew. And they told the doctors, and they had somebody else prepare the shots and hand them to the doctors. So the doctor just got a needle and didn't know whether they were getting the real thing or not. Why is that important? Because the doctors would judge later if they had the polio or not. And it's kind of a judgment call. I mean, if you go all the way to crippled, that's pretty obvious. But a lot of times it's a little bit more of a judgment call. They would look and go, yeah, are they starting to have it or not? So they knew if the doctor knew in their mind, oh, this is a person that got the real vaccine, or this is a person who didn't, they might fudge that a little bit. So they wanted to take that all out. So the doctor didn't know, patients didn't know, the doctors were just looking at people a year later, deciding whether they were getting better or worse from polio, based on that. And it was a very successful study. Sad thing is, I remember reading the study, there were like, the results were dramatically different. I mean, it was clear beyond any doubt. The Salk vaccine was really doing something. I remember it was kind of sad, there was like in the 100,000 kids that were randomly assigned that had the beginnings of polio and were randomly assigned to the group that did, no, they didn't have the beginning. It's a vaccine, huh? I'm medically not that great. Let me try that again. It's a vaccine, so it's preventative, right? So it's not a treatment that way. So anyway, so for the 100,000 kids that were assigned to the false group, like 2 or 3 of them died of polio because they were not given the real thing. And the other group, nobody died. And anyway, so the results were dramatically better, and then they knew it was working, and they gave it to the whole nation. So that was a double-blind experiment, and it got to the actual truth that way. All right, randomization. You got to do it randomly because otherwise you're going to pick samples that don't work. There's a great example of this. You know who the famous pollster of our time? We could switch gears to polling. Gallup. You've heard of Gallup polls? George Gallup? Not heard of Gallup polls? No? Maybe? Okay. So Gallup, I always think that's a common name. Gallup polls. So Gallup first became famous in 1936, I think it was. Anyway, there was a magazine called the Literary Digest magazine back in 1936. And they were predicting the winner of the election like a month before the actual election, successfully 3 elections in a row within like 1%. They were right in the money. And they got famous. This magazine got famous for that. So they predicted successfully, let me see, 1936, back up 4 years, 32, 28, even 24, I think. So the 1924 election, the 1928, and the 1932, I believe it is. If anybody has Google, you can type in Literary Digest magazine. Literary Digest magazine. So they got it right. They predicted the election ahead of time, like a month before. And the way they did it is they sent out like little notes in the mail to 10,000 people. And they said, who are you going to vote for? And people would write who they're going to vote for, mail it in, and the magazine would take in all those things, organize them, and they'd print the results in their magazine like in October, a month before November, before the election. And you'd be able to read there basically who's going to win the election. And they were right. 3 elections in a row, they were within 1%. They were like right on the money. So that was big news, right? If you can find out who's going to win the election a month before. That's big news. So their magazine was rocketing. And then in 1936, they predicted there was FDR was running against, and obviously he's the winner, right? He was our president. He was the longest term president because he was there through all World War II, like 3 terms or something. Anyway, FDR, and he was running against, I can't remember now because he didn't win, but he was running against the other candidate, the Republican candidate. FDR was the Democrat candidate. And the Literary Digest magazine predicted that the Republican was going to win, really strongly, like 63%. Now we have all these elections that are super close up, 51 and 50.3 or 49, But back then it was like 63 and 42. They predicted the Republican was going to win strong. They made this big boast, the magazine, we're sure, we're within 1%, we know it, here it is. George Gallup was a nobody at that time. He had a small little operation, and he only surveyed I think it was 600 people or something. Small sample, but he did it wisely. He mixed up his sample, and he wrote in his little magazine ahead of time that it was going to go the other way, that FDR was going to win, and then the actual results came down, and FDR, the magazine had it exactly opposite, terribly wrong statistics. In fact, the whole magazine folded after that. They printed an issue the next right after the election that said, "Is our face red?" right on the top. That they just admitted we were just dead wrong, and after that the magazine folded because who wants to read a magazine that just doesn't know what they're doing? They're just totally wrong. Why did they blow that study? Because there's a few reasons why we learned statistically why they blew that study. The design of their experiment was terrible because of a few things. Number one, what do you do when things are mailed to you? Me too. They go right to the trash, right? So what kind of sample is that? We talked about that last time. Voluntary. So whose opinions did they get? The extremists. They got the people who were really into the election, that really cared a lot one way or the other, right? They didn't get the average person's opinions because they did a voluntary sample. Whereas Gallup went around, he had a bunch of people working for him, and he sent them out, and they would meet people face to face. They'd say, "Hello, ma'am, do you have a second? Can you tell me who you know?" And if somebody's with you face to face, you might say no thanks, but most of the time you'll go, "All right, you're right here in my face. I'm going to vote for this person. Okay, thanks." You're likely to get a response, right? You're not going to get a bunch of. Whereas these stuff in the mail, most of the people's opinion you're never going to hear about because they're not extremists. So that was the first big mistake they made. Second is they sent. You know how they got the names for who to send Literary Digest, who to send it to? They went on new cars purchased. They had a list from dealerships of people who had purchased new cars, and phone records. Back now, a couple things to know. What was going on in 1936? Let's say I'm a wannabe history teacher. Depression. That was the Great Depression. So how many people were buying new cars? It was 25% unemployment. 1 out of 4 was out of work. Right? It was terrible times. People weren't buying new cars. And telephones, we didn't all have one in our pocket back then. That was a little bit more of a higher income thing too. So when they only asked people by telephone lists and car dealership and clubs, also they took like club things. Yeah, what do you got, Brian?
10 million.
Yeah, 10
They
million.
sent out
How many came back?
2.4
2.4%?
million.
2.4 million. Yeah, so that's like 20%.
Yeah.
Yeah, so they sent out 10 million, like who are you going to vote for? They only got back 2.4 million. So they're only getting back 20% of what they sent out. About. So that's terrible. That means 80% of the people never told them. They're not getting the opinions. And they, at the time, they thought, well, who cares? Those people didn't answer. No. That matters. That means you're just getting extreme views. Unless you're just getting extreme views. Now we know that really matters when you do a sample. You're just getting extreme views. You're not getting the truth.
The candidate was Alfred Landon
Of
Kansas.
Of
He was
Kansas.
the governor.
Okay, so anyway, so for that, what George Gallup did for the first time, that's when he became famous. He did what's called stratified sampling. He broke the nation, and he said, I'm only going to do, I don't know, maybe he surveyed 6,000 or something. Is that what it was? They probably said there. What is it?
10 million.
50? Did he survey 50,000?
Yeah.
Okay, no, I know the magazine did 10 million.
Oh.
Yeah, Gallup did 50,000, and he broke them into groups. So in other words, if our nation is, whatever, 70% middle class, he made sure 70% of the people he asked were middle class. If our nation was 52% female, he made sure 52% of the sample he looked at was female. If 33% of the nation lives in the country and 67% in the city, he made sure those percentages were true in his sample. In other words, he made his sample a little United States. So that he made sure what he found from his little sample really faithfully represented the whole United States. He didn't need to do 10 million people. He only asked 50,000, but he asked them wisely. He asked what's called, and we're going to get up to that, stratified sampling. He broke them into the correct groups that were a little mirror of the whole United States. In fact, here's my favorite saying from Gallup. He said, because people asked him, how'd you get it right with only 50,000 people, and the magazine got it wrong with 10 million? He said, you know what? If you stir the soup well, 1 little spoonful is all you need to know how the whole thing tastes. That's exactly it. He stirred the soup well. He mixed up his sample well. So it was a faithful taste of the whole nation. He had all the groups represented correctly in the percentages they really existed in the nation. So what he got was the truth. He became world famous at that point, and everybody since then basically follows his way. That's the way all scientific studies are done now, is by stratified sampling. Systematic sampling is when you grab like you do some starting point and select every kth element in the population. So you might say, all right, we're gonna see how these cars are coming off the assembly line. Is the upholstery being done well? And now they're not going to. They might look at every car, but a lot of we're getting into some of the people that use statistics a lot is manufacturing processes, because they don't have the time to look at every car or every radio being produced or every CD player or every cell phone. So what they do is they have a system. They say, we're going to look at every third cell phone coming off the line and make sure that it's in good shape. Or we're going to look at every 7th cell phone. And we're going to pick. So that's literally what inspectors will do. As the cell phones are coming off the line, they'll grab every 7th, pull it out, do a thorough test, make sure it's good. Now, could some other ones sneak by that were bad? Could be. But if you're checking every 7th one, are you getting to the truth? What are the odds that you're going to have a bad one sneak by? Well, we'll get into that later. That's all statistics. Like, do you need to look at every 5th one? What if you just look at every 1,000th cell phone? Is that good enough? Well, we'll talk about it. There's the less you look at, the more the probability that you're going to miss some bad ones, right? But it costs companies more to pay somebody to look more frequently. You get the idea? So statisticians come in and they'll tell the corporate people, if you only look at every 1,000th cell phone, you're going to have about 3% bad cell phones. Whereas if you pay a couple more employees and you look at every 100th cell phone, you look more frequently, then you're only going to have 1% bad cell phones. So what can you live with, and what are you willing to pay? Companies make those decisions, and it's statistics that determines, those percentages I'm giving you. We'll get into those later. So that's systematic sampling. Convenient sampling, that's what you don't want to do. That's what people do a lot. That's where you do your sample because it's easy. Like if I said, hey, I want to figure out the average age at Lemoore College here. So I'm just going to ask my class, because it's easy for me. You guys are right here with me, and I'll just take the numbers. Well, that's called convenience. That's convenient for me. But that's a bad sample, right? Because we're a night class, like we talked about. We're probably not very representative. If I want to do a good job to figure out the average age of students at West Coast College Lemoore, I would need to take a couple night students, a couple day students, a couple that are science, a couple that are more other fields. I have to move around campus to all the different areas, night, day, different days of the week.
Genders.
The genders. I'd have to mix it up like Gallup did, wouldn't I? To get a faithful average. Convenient sampling is what a lot of people do, and it's not believable. It just doesn't get you to the truth. All right, stratified. That's what we talked about. So that's where you break them into groups. That's like what George Gallup did, stratified sampling. So they're grabbing 3 men, they're grabbing 3 women, etc. You break them into what are called strata based on different characteristics. So gender, race, income level, live in the city, live in the country, age, all kinds of different things. That's what George Gallup did. He made sure that he had the right percentages for all kinds of different strata. Cluster sampling, that's when you just grab a bunch of different areas. So divide the population into clusters and randomly select some of those clusters, choose all the members. So they might say, I'm going to survey the average age of people in the city, and so I'm just going to grab a whole bunch of people at this location, a whole bunch here, and a whole bunch there. That'd be cluster sampling. That could work as long as those areas have a variety. If it's like where all the young people live or the old people, then that's not going to work. You'd have to.
So that still leaves room for error.
Yeah, it still could be. There are some forms of cluster sampling, if they're wisely done, that could work. It depends. It sort of depends. That alone doesn't mean something for, whereas convenient sampling, that's pretty much always bad. Cluster sampling is a style, and it could be problematic, but yeah. All right, confounding, we've talked about that. I didn't give you that name. I called it a lurking variable. That's like, when I did the milk cancer thing or the Boy Scouts becoming criminals. Remember what the lurking variable, when I said, hey, states that have more Boy Scouts 20 years later have more Boy Scouts 20 years later, more criminals, right? But Boy Scouts are not causing people to become criminals. What was the lurking variable? What was the confounding variable? What was really causing this to happen? Population. It was just states that had more of everything. They got more Boy Scouts, more criminals, more non-criminals, more everything, right? So the lurking variable or the confounding variable in that case was population. So that's the item that's really at work. That's what that is. And it's confounding the experiment. So that's why you plan an experiment so you don't get fooled by that, right? So if you really wanted to know if Boy Scouts were causing criminals, you would have a group that's Boy Scouts and a group that's not, and watch just those groups 20 years later. Then you would know Boy Scouts are not making criminals. All right. Sampling errors. No matter how well you plan, execute, there's always, what about luck? Doesn't luck happen? It does. And we have to worry about that. We have to think about that. Random stuff can happen. And that's a lot of the math we're going to do in this class is say, what is the chance of random stuff? So we'll get into that. Now there's non-sampling error, you'll see let me just skip over that, and we'll see it in the problems. It'll make more sense when we see the problems, and here are the problems. Speaking of that. All right. So let me go to the end here. Things. All right. So determine whether it's an observational or an experiment. So here's the homework. We're in the homework. This is similar to what your homework will be like. So is this going to be observational or experiment? 432 boys with a particular disease. The subjects were photographed daily of how their disease is progressing. Yeah, that's observational. Why is it not an experiment? What would an experiment be?
Not given anything.
Yeah, you got to do something to them. You got to treat them with something. They're just being observed, huh? So that is observational. Number 2, explain the difference between a single blind and a double blind. I'm sure you can do that, right? I don't know if I want to read all those words. There's a lot of words there. All right. Let's see, which one is it? I think we all know, it's just which one of those says it? Is it a single blind,
Yeah.
subject does not know, in a double blind, neither the subject nor the researcher in contact with the subject. Yeah, there it is. Good. I don't want to read anymore. It's A. It is. Good. That's nice when it's A. All right. Number 3. Okay. So number 3. A study of an association between which ear is used for cell phone calls and whether the subject is left-handed or right-handed began with a survey emailed to 5,000 people belonging to an ontology. What's ontology?
Say here.
Ear and
Oh,
hearing.
okay. An ontology online group, a hearing online group. And 717 surveys were returned. Ontology, it's out there. It relates to hearing and hearing. All right. What percentage of the 5,000 surveys were returned? Okay, so of the 5,000 surveys, what percent were returned? Can we figure that out first off?
14.
Yeah, how'd you come up with that?
You divide 717 by 5,000, and then you times it by 100.
Good. So 717 over 5,000. Yeah, would you say it came out? 14?
Well,
J-
14 point something, but they want you rounded to like the nearest.
Oh, do they? Oh, yeah, round to the nearest whole number. Okay. So it comes out 0.14, blah, 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 and we just make it, you just move the decimal 2 places, right? 14%? We good there? So 14% returned the surveys. So what this response rate, and what does not appear or appears to be low. Yeah, that's low. Yeah, that appears to be low. You see, you understand the problem. So what is the problem with a very low response rate?
It creates a biased sample that consists of those with a special interest in the topic.
Yep. Well said. Did you read those words? That's just
Yeah.
okay. I mean, that's beautifully said. Yes, it creates a serious potential for confounding, which creates a serious potential. No. It creates for getting a bias sample that consists of those with special interest. Yeah, the extreme people that have a special interest. Yeah. Good. That makes sense. So low. That's what the Literary Digest magazine. The whole thing. They were big. They were like Time magazine or something. They were Newsweek. They were the biggest magazine in the nation in 1936. This was big to them. This wrecked them. So the son, my 14-year-old son uses that word all the time. So I'm getting used to it. It wrecked them. I just think it's a funny word. So anyway, so it wrecked the whole magazine. Went down because of that. Identify the type of sampling used, random, systematic, convenient, stratified, or cluster, in the situation. A researcher selects every 787 social security number and surveys the person. That's a system, huh? That's a system. You know, have you heard that sometimes they do tax audits that way? They'll just, no, not always. They also look for certain markers, but they also kind of do like every 1,000th tax return, you know. But they also look for markers. But anyway, that would be a system. That's systematic sampling. Number 5, identify the type of sampling. In a poll conducted by a certain research center, 1135 adults were called after their telephone numbers were randomly generated by a computer, and 61% were able to correctly identify the president. Well, that's good. President of Uruguay. No, of the United States, I have to say. Yeah, so what do you think about that? What do they do? Is that convenience? No, that's random, isn't it? Yeah, that's random sampling.
It was randomly generated.
Yeah, randomly generated, exactly. That's right. Yeah, so that's just random sampling. That's good. All right. Okay, so number 6, to determine customer opinion of their check-in service, American Airlines randomly selects 80 flights during a certain week and surveys all the passengers on the flight. So American Airlines is trying to check on how their customer service is going. So this is something they do, and they use statistics to make sure they're getting stuff. So what kind of study is that? If they grab 80 flights in a certain week and survey all the passengers on those flights. Yeah, do you see that's cluster? They're grabbing 1 week and just doing everything on that week. And it's not necessarily bad. You see how I mean? It's not necessarily bad. That could be a good way to survey. They just, rather than grab 2 passengers off every flight, that could get a little old. They just say, let's just go crazy in a certain week. Now, there can be problems with that. if that was a bad week or a good week for weather, for whatever, then you could get faulty data. So you got to watch out for that. But if it's a pretty average week, that might be a good way to go. So number 7, to estimate the percentage of defects in a manufacturing batch, a quality control manager at Daimler, how do you say that? Daimler, thank you. Daimler Chrysler selects every 17th van that comes off the assembly line, starting with the 3rd until she obtains a sample of 140 vans. So that's a system, huh? Right? So she starts with the 3rd van and then adds 17, every 17th after that. Yeah, it's a system. It's a system. Okay, so on number 8, a man experienced a tax audit. The tax department claimed that the man was audited because every 5,000th person on the taxpayer list was being audited. What's that one? Yeah, that's systematic again. That's a system. Number 9. A market researcher has partitioned all residents of a certain region into categories of young, middle-aged, senior. She is surveying 40 people from each category.
Stratified.
What's that?
Stratified.
Stratified, exactly. That's stratified. See how they broke it into different strata? Right? Different ages. Young, middle-aged, senior. That good? So that's an example of stratified. That's what George Gallup did, and he did it for more than just age, all kinds of characteristics. That's stratified sampling. Okay, identify which types, blah, blah. Radio station asks its listeners to call in their opinion regarding the use of pesticides in residential areas.
Convenience.
Yeah, that's just convenience, right? That's just what's easy for them. And that's why is that a lousy way? If you want to get to the truth, that's not going to get you there. Why not? Yeah, it's just volunteer, right? Who's going to call in?
People care.
Yeah, the people that are really all worked up about it, one way or the other, huh? You're not going to get the average person's opinion. But that's what you hear a lot of. Okay, so determine, same kind of thing. So number 11, in a survey, 1,465 internet users chose to respond to this question posted on a newspaper's electronic edition. Is news online as satisfying as print and TV news? 52% of the respondents said yes. Okay, so what's their question? This is we're supposed to go down here. Yeah. So number 1, you're supposed to choose among those options. Number 2, these options. And then this will be the final thing we do. A, B, C, D. So first off, blank number 1, we're supposed to say observational or experiment.
Observational.
Did they do anything? Did they treat them in any way?
No.
Yeah, it's just observational, huh? Is the news? Yeah, they didn't treat them in any way. They didn't give them anything. So that's just observational. That's what goes there. Observational. This is an observational study because the researchers, now we go down to number 2 here. Which one of these is it? Do not attempt or apply treatment to. Yeah, do not attempt. Do not attempt. Do not attempt to modify. They don't change the people, they just ask them what they think. So what's the major problem with this study?
It's a convenience sample.
D.
Yeah, right. It's a convenient sample with voluntary response again. It's so often done. It's funny. It's commonly done, and yet people tend to believe it, but it shouldn't be believed. Is news online as satisfying as print and TV news? So only 52%. So they didn't tell us what percent responded. They just told us that 1,465 chose to respond. We don't know how many they asked. I mean, they just put it on their website, so we don't know. So it's voluntary response. That's not good. Won the election. Oh, was it time with Gore? Yeah, it was that really close one with Gore, right? Remember that year when Florida determined the whole thing?
Yeah, they do recounts and everything.
Yeah, and all the recounts. But one of the things that was funny is I remember there were exit surveys from the polls that were done. So in other words, people wanted to know, so close, who's going to win. So some of the pollsters went up to people as they were coming out, having just voted, and they asked them, hey, who'd you vote for? And then they recorded it, and then they reported that to the news, because the news was trying to get out who was going to win, and everybody wanted to see. And they ended up reporting that Gore had won, not just because of a tiny little adding mistake, but it turned out upon later looking back, pollsters examined what went wrong, why they get such a strong false information on that one. It turned out that they discovered that people that were voting for Bush, for whatever reason, were less inclined to talk about it afterwards than people voting for Gore. People voting for Gore were more eager to, so people would come out of the polls, one voting, having just voted for Bush, one for Gore, and they'd ask them both, and a lot of the Bush people would just go, I don't want to talk, they just move on. And the Gore people were like, yeah, I voted for Gore. They were just more eager to talk. So they got the percentages wrong. So you just have to be really, really careful, because there's all kinds of different characteristics that people have. So you have to design your studies carefully if you want to get to the truth. It really is tricky. So people have been fooled a lot over the years. A study involved 22,071 male physicians. Based on random selections, 11,037 of them were treated with aspirin, and the other 11,034 were given placebos. The study was stopped early because it became clear that aspirin reduced the risk of myocardial.
Myocardial infections.
Thank you. How do you say infarctions?
Myocardial infarction.
Okay. By a substantial amount. I don't think I've seen the word infarction. What's an infarction?
Heart attack.
Heart attack.
Oh, you guys are like,
Total occlusion of a coronary artery causing a state of hypoxia or anoxia to a segment of the myocardium.
you could be like a doctor, Brian. I do this, though. This is the one I am a believer in. I take a baby aspirin every day because my doctor says studies have proven that it helps. So every day I take a little baby aspirin. So I'm a believer in this study. So anyway, so they did 22,000 male physicians, 11,000 of them were treated with the aspirin, 11,000 whatever, just the placebo. It was stopped early because it worked, right? It reduced the risk. So let's talk about the study. So number one, is it observational or experiment? Yeah, because they're treating them differently, aren't they? Some are getting the baby aspirin, some are getting the fake, the placebo. So this one is an experiment. Because the researchers apply a treatment. Blah, blah, blah. Apply a treatment to individuals. But there is a problem with this study. I don't know. I don't think it's a bigger problem, but the book does. So maybe I'm wrong. I don't know. So they're going to claim there's a problem. I think it's a pretty good study right now. Anyway, the book has a problem with the study. So can you see any, they're kind of right, I guess. They're being pretty picky, I think. The results apply only to individuals with heart. Oh, do they all have heart disease? I don't think they all had heart disease in the beginning, did they?
They're all male physicians.
They're all male physicians. Yeah, that's the answer. That's what the book wants. Yeah, you're right. I mean, we're not getting females. We're not getting people that aren't doctors. Maybe doctors have less stress. So that's kind of a special group. I guess they're right. Maybe I'm being too loose. Yeah, so they're saying, you just took male doctors. That's a certain kind of person. It's not like everybody. And that's true. They're right. I guess that's a little specific. So yeah, that's what they want on that. Okay, how are we doing? Okay, so a medical researcher tested for a difference in systolic blood pressure levels between male and female students. Well, I don't know what was over there. What word was over there? Male and female students. I don't know. It's gone now. Yeah, 12. So the blood pressure levels between male and female students 12 years of age. She randomly selected 4 males and 4 females for her study. All right.
Observation.
Is that observational or experimental?
Observation.
Yeah. We're not giving them anything, are we? We're just observing them. And what comes here? The individuals, what does not attempt to modify or applies a treatment to? It does not attempt to modify. And what's the major problem with this study?
The sample is too small.
Yeah, I guess that is kind of a small sample, just 8 people, huh? Yeah, it's kind of small. A lot of chance for luck when you only do 8 people, and we'll calculate that stuff later. So right now we're kind of doing the big picture. Later we'll get all the numbers. Like, what is the chance that you just get luck there? It's pretty high if you only do 8 people. Okay, so number 14. A sociologist has created a brief survey to be given to 2,000 adults randomly selected from the U.S. population. Here are her first 2 questions. Number 1, have you ever been the victim of a felony crime? Number 2, have you ever been convicted of a felony? What's the problem with this study? Oh, wait, no, that's the last question, sorry. I forget the plan here. Number one is this. This is an experiment or observational study? Yeah, they're not changing them, are they? They're just observing their behavior or their experience. So observational. And number two, does not modify, right? Okay, now what's the major problem with the study? No. See, individuals convicted of a felony are more likely not to answer the second question honestly. Yeah, that makes sense. If it was a test, though, I would read them all, just to be sure. I mean, that sounds pretty good to me, but let's read on. There's no blinding or replication. It doesn't matter. Blinding is only when you're giving them a treatment, right? We're not giving them a treatment. The responses will be voluntary, which will lead to a high chance of bias. Well, yeah, that does. No, they're not voluntary. They grabbed 2,000 adults. They didn't just like post it on a website and then whoever answered. They specifically grabbed 2,000 people. So that's not voluntary. That's the difference. You tracking with me on that? So something's voluntary if you just put it on a website or put it on a radio station and say, hey, call in or text in or whatever your opinion. That's voluntary. A bunch of people don't do it. No, this is not voluntary. They grabbed 2,000 people and asked them, and they answered. So D, the sample is only U.S. That doesn't matter. So yeah, it's A. Yeah, you guys are right. So it's A. It is A. They won't answer honestly about that, perhaps. Number 15, which sampling method divides the population up into sections, randomly selects some of those sections, then chooses all the members from the selected sections to study? Divides up. Yeah, what do you think there? It divides population into sections, randomly selects some of those, then chooses all. Yeah, that all word. Yeah, that seems like cluster. All the members from the selected sections. Well, honestly, I'm a little confused. Is it cluster? Yeah, that's a close call. Yeah, that's very similar to stratified, isn't it? But I guess the all is the cluster on that. Okay, which sampling method subdivides the population into categories sharing similar characteristics and then selects a sample from each subdivision? Stratified. Yeah, there's stratified, right? That's like what George Gallup did. He broke the whole population into groups and then, selected a little bit from each group on that. A funny thing, let me finish with this, with the George Gallup thing. George Gallup became super famous in 1936 when he got it right with his 50,000 and the Literary Digest magazine went down. And so after that, everybody did Gallup's way, stratified polling. That was the thing. Everybody started imitating his methods of sampling. And then he got it right in 1940, Gallup did. 4 years later, the election, that was easy when FDR was president in the middle of the war. We didn't want to change presidents. And in 1944, FDR again got it right. The war was still going on. 1948, I believe. Yeah, you guys have your Google? I believe it was the presidential election of 1948. Dewey and Truman, I think. Anybody have Google? Can verify whether I'm making stuff up here? I love Google. This is great. You can know, what's true or false at any moment. So anybody have it? 1948 presidential election. Wasn't it Dewey and Truman?
Dewey.
Yeah, good. Okay. That year, George Gallup got it wrong. And all the other pollsters that were imitating him actually got it wrong. And now, why people, there was one more lesson to be learned from George Gallup. There's one thing they learned, and then after that, they've been good. What it was that Gallup and all the other people doing his same method learned that year in the wrong prediction. They predicted Truman, right? Eileen. Didn't they predict Truman and Dewey won? Or was the other one? Okay, I don't know who won. I just know the two people. Truman won, they predicted Dewey?
Yes.
Okay.
I had the paper right there.
Yeah, the Chicago Tribune. That's the hilarious part. Yeah. So the pollsters were getting so good. The George Gallup and all the people doing the same method, the stratified thing, everybody just started believing him, like really believing him, because he got it right in 36, 40, 44. So when 1948 came along, and it was Dewey and Truman, so Truman won, right? Yeah, Truman won. Yeah, Truman was the one, no, it wasn't even one that took over from FDR. Not Truman? I know, I'm getting confused, whatever. Anyway, so they were running and everybody was getting so confident in these methods, like too confident, that the Chicago Tribune, I guess they didn't want to stay up late? Or what? I don't know. This is a major newspaper, a Chicago Tribune. They went ahead and printed that Dewey won before they saw that he lost, because they believed George Gallup's prediction so strongly, and I guess they just didn't want to stay up late. So they put right on the front page, Dewey wins! And they rolled it to press. And it went out. And then the results came in. And Truman won, right? Truman won. And there's a famous piece of American history where, as he won, on the acceptance stand, he holds up the Chicago Tribune, which says, Dewey won. It's Truman standing there, and he goes, ain't the way I heard it. You know, and that's the famous American statement in that situation. Why did George Gallup and all the other people get it wrong that year? They were close. They weren't far off. It was a very close election like the ones we've had the last few years. Very close election. So it wasn't like they were whoppingly off. Is that a word, whoppingly? They weren't a long ways off. They were close, but they got it a little bit wrong, and here's what they learned. That what George Gallup was doing the whole stratified thing, maybe 50,000, and sending out his pollsters, and he would have so many men, so many women, so many this race, so many that race, so many rich, poor, middle class, country, city, all the different kinds of people, and he would figure out a little microcosm of the United States and send out his pollsters, but he gave them choice beyond that, and didn't use randomness. In other words, he would say, suppose Val was one of the pollsters. So George Gallup would lay out the whole plan, and so Val's one of the pollsters, and he would say, okay, Val, I want you to go find 5 men that live in the country that are middle income, and that, I don't know, what are some other characteristic, that are Asian. Go find those. That's what you got to find. 5 men that live in the country that are middle income and that are Asian, and find out who they're going to vote for. And then somebody else would have another assignment, right? He gave the assignments, so they put that all together, it'd be a little United States, right? He had the same amount of percentages. Well, he gave them choice. Other than they didn't have to random. Val's assignment was just go find 5 men that are Asians living in the country, middle income. And it turned out that when people are giving, a pollster is given choice, they tended to prefer the Republican voting people. Isn't that weird? Like, why was that? That's what they learned. You can type it in Google, learn that. The pollster, maybe George Gallup was Republican. I don't know why it was. But not just Gallup, all the other pollsters as well. All the pollster agencies at that time, the people that were pollsters, that went out, and they had their choice. They would look at different people and go, there's 2 or 3 Asian men, middle class, that are living in the country. I'll talk to that one. Right? For whatever reason, they were attracted a little bit more. It wasn't a big difference. It was a very close election. But they were attracted a little bit more, the pollsters were, to people that were going to vote Republican. And that made the Republican vote go higher than it really was. Right? They were getting opinions more from Republican voting people than was really representative of the whole United States. And they all were, not just Dewey, they all did. And so they predicted they put a little too much on the Republican, and they thought Dewey was going to win. When really, it was very close. It wasn't a big difference, but Truman actually won. And so what they learned after that is they go, okay, we've got to put random, because if the human element is involved, it can muck it up. Right. And so in the end, you've got to do I've got to give Val his assignment, 5 Asian men living in the country, middle income, but then I've got to take all the Asian men, middle income living in the country that are in a county, for example, put them all into a computer, and have the computer randomly grab 5, and go talk to these 5.
Right.
And so you don't have a choice. You've got 5 randomly picked, and that takes the human element out of it. That's what they add to it now. You're up to date now. That's the current polling method. That's what they do. They stratify it and then put in the random effect because it takes out the human element. That was the one last lesson they learned about wise polling. Take out that human element, and then you'll get more to the truth. Chicago, but the funniest thing to me is, I never had a chance to. I love history. I would love, I won't do it tonight. I got too many other things to do. But I would love, maybe in my next break, to read why in the world did the Chicago Tribune, did they just not want to stay up late? I mean, that seems so lame. A major paper like that?
I wanted to be first.
Was that it? Did you read something about it? That makes sense. That makes sense. That probably is it. You probably got it. Yeah, it's just hilarious that they printed before they actually saw the news and they got it wrong. All right. Well, let's